Okay, it's 11 o'clock. Let's get started. So what we want to show today is how the Softree Optimal software works. And the first thing I'm going to show you is how it can be used to speed up the vertical alignment process. We're using Softree Optimal inside of a road design package called RoadEnch, which I hope many of you are familiar with. But the Softree Optimal technology is independent of the RoadEnch software, and in the future it may be available in other packages. So let's start off by looking at a road design that I've created. I'm just going to open up the there it is. This design was created from that terrain, and it consists of nothing but a horizontal alignment. So let's take a look at the plan window here. There it is. And as you could see from that surface, it's fairly, let's just bring that to the front for a second. The surface is fairly rugged, but the road is kind of finding its way through the steep sections. This is an existing logging road, and we have access to this data, so it's nice and convenient. And I'm going to assume that what we want to do here is improve the quality of this logging road by making it wider and raising the standard, the design speed, etc. So I did that in our road design package. I created an alignment, and you can see the old logging road alignment. It's in kind of yellow there in the background. And I used our software here to try and track that as best I could while maintaining a design speed that was reasonable. So for example, if you look at this area here, the design speed has been reduced to 50 kilometers per hour, which is a lot faster than the old logging road. And that still produces a curve that there's no way we can track the logging road. But then further along, I was able to put in curves with 60 kilometers per hour, like this one here, and I was able to track fairly close to the old logging road. And then in this area, here's the cross section. You can see the old logging road profile there. In this section, I moved over a little bit because I didn't want to go up this, cause a lot of rock cut in the hill here. These are all tools that come with the road design package. Haven't shown you anything about the optimal yet. Okay, so we've got a horizontal alignment. We want to build a vertical alignment. The process manually is to start by designing vertical intersection points in the profile window. I'll just show you a couple. Let's see, I'll put a point up in there, and that's pretty steep. How steep is that? That is actually 7%. Okay, that seems reasonable. I'll put a point down here. That's minus 10.2. Let's move that over a little bit. Oh, now my grade is only minus 7. I better put a curve on there. And there's a vertical curve. Wait for it to re-update. There we go. So, and it's calculating the mass haul and so on. Now this process to build the entire vertical alignment would take a while, especially if I were going to do a good job of it and make sure that I had a balanced road and so on and so forth. So let's just undo that. Delete the vertical alignment. And now I'm going to design a vertical alignment with the press of a button using Softree Optimal. Softree Optimal allows you to calculate costs of an alignment based on cut, fill, and haul. So let's take a look at the options here. Each material that you might cut has a cut cost associated with it, dollars per cubic meter, and an embankment cost. So, you know, it costs money to usually compact your material, so there we go with the embankment cost. In addition, when you move material around, that costs money too. So we've got a haul cost, and the haul cost is not just per cubic meter, it's per cubic meter times kilometers. So the further you haul it, the more it costs. And we've got 3 levels of haul here, free haul, overhaul, and haul. Let's go on and calculate an alignment. So first of all, I can figure out the cost of building a road along the ground. That's kind of uninteresting. Let's just calculate an alignment. So I'm going to call this from scratch. And this alignment will, okay, I'm going to calculate cross sections. Good, every 20 meters, that sounds reasonable. I've got some pretty big bumps in the ground, so I'm going to allow the optimizer to go 10 meters above and 10 meters below the existing alignment. The existing alignment is the original ground. I want to make this about a 60-kilometer road, so I'm 60 kilometers per hour, so I'm going to put in a K factor of 20K, or 20 meters per percent. Got minimum, maximum grades. They're pretty big, but this used to be a logging road, so it is that steep. To reduce these grades would cost an awful lot of cut and fill, so let's leave it at 10. We've already set up the material costs, and I think I'm ready to go. Let me just set a couple things in here. This is more technical stuff. I'm working with a debug version of the, not a debug version, a testing version of the software, beta version. Some of those options won't be available in the future. Basically, we're telling the software here that we want to have curves of 50 meters and there we go, that looks right. This is probably the only option that will be in the final release version. How long do you want your curves to be and your tangents between curves? Let's just see how it works now. So what it's doing now is calculating cross sections, providing data for the optimizer. This road is a little under 2 kilometers long. As you can see, it's got lots of topography to it. Now it's calculating a optimal solution, and now it's recalculating the cost based on the alignment that was found. Finished. Now that did take a few seconds. Actually, it says here on the bottom how long that took. 18 seconds to find the solution. No point comparing this with the original ground solution because that really is not a solution at all. But it has calculated a cost, $500,000 to build this, and that's based on those costs we put in there. It's important to note that the cost calculation is only for the earthwork. We're not costing pavement or culverts or other similar items. And from the point of view of finding the best alignment, those costs don't change much when you change the alignment. So they don't really change the best alignment. They just add to your cost at the end. Right. So that green line there is the alignment that was calculated by the optimizer. Let's set that as my current alignment, and you can see the curves that were calculated. There it is. Just zoom in a little bit on that hill. So there's that 20K curve. Let's take a look at some of the cross sections too and see what we've got here. So down near the beginning, we're climbing quite steeply. So this section here is in that climb. Hard to see what's going on with this tiny screen I'm working with, but it goes faster over the internet. So there we are. There's the steep section at the beginning, and that's what the cross section looks like there. As we move through the alignment, you can see we're basically staying near the ground. There's a little bit of cut. That was easy. I created a vertical alignment with the push of a button, and it seems reasonable. Now I'm going to refine that alignment a little bit and make sure that I'm getting absolutely the best I could. So I'm going to take this one, make it into a, let's call it trial 2 optimization, and I'm going to increase the number of points that I use to calculate the alignment. I'm going to decrease the allowed variation. and rerun it. Now, what I'm doing here is really all I'm doing is giving the optimizer a chance to be more accurate. It's not actually necessary to do this. I could just stop and say I finished. But just to illustrate the general process you would go through, I'll do this. So I'm going to reprocess this trial. Oh, and I want it to look different. Let's just change the color. So the first optimization, I gave it a 10-meter, whoops, it's not being displayed. I gave it a 10-meter offset. The second one, I'm going to give it a 2-meter offset. Let's see how that goes. Oh, this is going to take a little longer. Now, while that's calculating, let's just take a look at some other stuff I've been working on. So I'm going to open a new version of location. The optimizer does take a long time to run in some situations, and you can run our software in multiple instances. So there's no problem with, for example, designing one road while the optimizer is optimizing another road. You can do those things at the same time. You don't have to wait for it to finish. Now, we've got a solution in here. What I wanted to show you in this alignment is that, well, first of all, let's take a look at the cross sections we've got here. In this road, I've actually put in a passing lane that goes up the hill. You can see as I move my cursor along the plan window, there's a gray line that moves in the profile window. So I've got a passing lane there. Let's just zoom in a little bit so you can see it. So you can see that the lane is wider on the right-hand side. I've got a passing lane going up the hill. Now, what else have I got in my cross sections? These are not just any old cross sections. They're real, calculated, multiple layer, real ditches, and in our cross section editor we can see how they behave. Let's move along to an area where there's some rock in the ground. I think I put some rock in the ground over here near this steep hill, and you can see that now I've got multiple layers in the ground, and if I have a cut, it's going to actually cut some of that stuff. There we go. So this little bit here, it's cutting rock. Above that, it's cutting glacial till, or, well, we're actually in the roadway here, so that's probably a poor assumption. But, and we've got some stripping going on. This is a realistic road design. It's the optimizer's taking into account all of those cross-sectional areas and volumes when it's doing its work. By the way, the other optimization is probably finished. Let's just take a look at it. That's the wrong one. Real-line 3. Where's real-line 2? Or 1? There it is. Oh, okay. Good. That's the one I wanted to look at. Right. So trial 2 solutions found. We take a zoom in here and see what it shows. And you can see it's just slightly offset from the first one. And the cost difference is pretty small. Now, the cost of the more accurate solution is just a little bit lower than the first solution that I found. It could have been higher because I didn't change any parameters. All I did was make it more accurate. But now I really trust this solution. I'm happy with it. It's been calculated with lots of points, with a good ground, good cross sections. I'm finished. I can take this alignment and I'm finished. What if I want to make some changes to it? Well, there's various things you can do. First of all, if I want to just change something manually, I can turn on this little auto process thing here, make a little change. Notice that let's just update the cost. The cost here is $531. That's the existing alignment. Let's set it to the trial 2 solution. Now my cost is very close to the cost that was found for the these numbers should be exactly the same. They're not, because I'm not actually doing the same cost process. If I do a formal recost by clicking on yes here, it goes through convergence process and finds the best spacing to calculate the most accurate cost possible. But I've got a very small difference here, so I'm comfortable with that. Now, watch this. Got a cost, $537,000. Move the alignment down a little bit. Dynamically recost that. Now it's $695. Oh, that's more expensive. Well, one would expect that if we deviate from the optimal solution. But maybe I need to do that. Let's just undo that. Now, what if I need to, for example, meet an exact elevation or grade because of control points? Well, I can do that too. When I do my calculation of the optimal alignment, I can tell it to tie to existing alignments. For example, this is actually joining a road at each end. It's kind of hard to see on the plan because I don't have a feature on here, but there is a road right there, and there's another road at the other end. So the elevation should be the same as the ground. If I look at the solution, you'll see that, oh yeah, there's a little difference there. Not very much, but there is a difference between the alignment and the ground. So I'm just going to put in a control point. Put one at the end. And I'll say I want this alignment to be, well, I don't know what it is yet. The existing alignment right now is not going to work because I got one already. Let's see what the elevation should be. It should be on the ground, and that elevation right there is 157.6. Okay. So we'll go into my control point, and I'll change that to 157.6. Same at the beginning. If you've got an existing alignment, if you've gone to the the trouble of creating an alignment, so I want this one to be at elevation 136.3, is that right? Sure, 136.3. So we'll add one at the beginning. And let's make that 136.3. Now, whoops, I hit the wrong button there. Okay, what about grade? Well, if we're coming off an existing road, maybe we have a grade limit too. So I could actually say, well, you know, I don't want to go higher than 3 plus or minus 2% grade, leaving that start coordinate station 0. Now, if I recalculate my optimal solution, it will honor those control points. You can put in as many control points as you want. In a situation where the alignment is completely constrained, then you won't get any freedom of movement. I guess there's another situation that can occur where you're constraining the optimizer too much and it fails. You can tell it to meet control points, and the control points are simply impossible to meet. That's one situation. The other situation is your initial alignment could be way outside your design parameters, and then the optimizer will say, okay, I can't fit an alignment that meets your parameters near your optimal. Okay, there it is. Now that's right on the ground. So it's found a different solution. How different? Well, it's certainly different at the beginning there. We expect it to be similar in the middle, and it is. The blue line and the green line are very similar, and the red line, I mean. Good. So that's my new solution. Let's set it current and recalculate. And now the cost is going to be a little bit higher. We'd expect $541 instead of whatever it was before. Okay. Let's try some what-ifs. How good is this tool for allowing you to change horizontal alignments? Find the optimal this cross section near, I think it, where was it that I was looking that looked interesting? I'm just going to look for an area where I've got large, here we are. Look at this. This cross section here has big fill. That's got to be expensive. And it could be moved horizontally here to produce a small amount of cut and a small amount of fill. Maybe that's a better way to go. So this is near station 1180. And I'm going to move the horizontal alignment over and A, find out what that cost me without changing the alignment, and then B, do another realignment, do another vertical to see if it comes up with a cheaper solution. Okay, so here we go. Let's take this IP and move it over a little bit. And let's take this IP and move it over a bit. Now you can see what it's done in the cross-section window as we step through that area. I'm now, yeah, so there's the area before where I had the sliver fill. Remember, it was 1180, and that fill has been reduced a lot. Great. Oh, I didn't have auto process turned on. Let's just turn that on. It was at 541. Let's reprocess, and now the cost is 545. Okay, it didn't change the cost very much. Let's try reoptimizing and see what that does. Okay, this is going to take a little while, so let's do something else while it's doing that. But you get the idea. What you can do is you can try different what-if situations and see what happens. Here's another possibility. Well, we've designed this road with a 60 kilometer per hour set of vertical curves, but I know already that the beginning of the road is so curvy that all my horizontal curves are set to 50 kilometers already. So that one, for example, is a 50 kilometer curve. Okay, well, what can I do with vertical curves if I want to be at 50 kilometers? Well, a 50 kilometer vertical curve would allow me to go down to K of 8. Well, let's round that up to 10. Okay, so I'm going to set the vertical curvature to 10 near the beginning of the road and see what happens. Okay, so let's create a new trial. So I will create a new one. Let's call it trial 3, 50K. What station should we go to? How about 500? Okay, so how do I do that? Well, I go into my constraints and say that the K factor is only 10 meters per percent, and we'll do that from the beginning up to 500. So I got different constraints for different station ranges, and better change the line type, or we're not going to be able to see the difference here. Let's change that into a dashed one. Okay, recalculate. That should do it. I think I've done everything right. So while this is calculating, let's go back to the other one and see what we found. It's finished. Oh, the cost was almost exact. Oh no, there we are. Sorry, $497. The cost did go down. So let's take a look at the profile and see what it did. It's found quite a different solution. The this one is the blue one, right? Yeah. So just by changing the alignment in that area near 1180, it's found a completely different solution in that area, and it actually did reduce the cost. Oh no, yeah, it did reduce the cost. So here's the cost of the current alignment, which is the alignment the vertical alignment that I created before, and it's at 545. Right? That's up to date, 545. And here's the cost of the new vertical alignment, 497, and the cost reduction is 10%. No, 9%. But that's still a significant improvement. So just by making that little horizontal alignment tweak, I've saved 10%. You can also use that as a route analysis tool. Like, what if I went on the other side of that hill? So I'll design a horizontal alignment there. I can use the costing tool to calculate the cost of that earthwork at any time, but it takes a while to build a vertical alignment. So I'll just use the optimizer to calculate that vertical alignment, and I'm instantly looking at costs. Not quite instant, but pretty quick. I heard the bell ring, so that means alignment 3 has finished calculating. Let's see what we did there. So remember, I was going to reduce the speed near the beginning. And, oh, that's funny. You know what? I think I made a mistake here. Let me go back to constraints, 1010. Oh, that's interesting. I didn't make a mistake. It's there. Okay. Got too many things on display here. So let's turn this off and turn this one off. And this one, I just want to look at the alignment. There it is. Okay. Yeah, so it is quite a different alignment. And the reason it was able to do that is because it had more flexibility. One thing that is important to notice here, let's turn on my vertical band. Yeah, there we go. Okay. It probably would have gone further down, but it ran out of room. In this trial 3 here, I said don't move more than a meter. I set this up yesterday when I was playing around with it. Don't move more than a meter when you recalculate this alignment. That wasn't enough room to really see what's going on. So let's bump that up. Do it again. Won't be as accurate, but it'll give me perhaps even a lower cost. Okay, so my alignment number 1, I made a small horizontal alignment change, and I reduced my cost quite a bit by 9%. And that is the idea. You can move your horizontal, you can move your vertical, you can put in control points and recalculate, find out whether you've made it as an important change that's going to increase or decrease your costs, or whether it's not going to make much difference. Got a couple of questions. First question, we are recording this session. It's available afterwards. If you just go onto our website and look in the, let me just go there and I'll show you real quick. Okay, why is it not opening Softree? There we go, I must have clicked somewhere else. Okay, so we have free web seminars every Friday. It's right on the front page. If you click in there, there is a list of what's available in the future, and previously recorded, there's a link there, so you can go in there and you can download any one of these movies. They're fairly hefty. Most of them are an hour long, so it takes a while. And this Softree Optimal demo will be in there. Maybe we'll shorten it up a bit by taking some stuff out, but essentially it'll be there. Second question. Tyler is asking me a second opinion after you've manually created. Yeah, okay. He's pointing out, I think, Tyler, that once you've created a vertical alignment, you can just use the optimizer to find for you an alternate vertical alignment and immediately compare costs. It always comes out cheaper. That's the whole point of optimization. And if you put in the correct control points, the optimized solution should be better than the manually designed one. If, however, you're not the one who's doing the designing, if you just want to look at somebody else's design, you could use this tool to do a quick analysis and see if they're close to optimal. You know, if they're within a few percent, well, that's fine. We'll use their design. If not, maybe you want to go back to the designer and say, hey, you could improve costs here. One of the problems, and it's a real problem when you're working with the optimizer, is that if you don't have all the control points or the information about what's in the ground or other important information, like we can't go here because it's swampy ground or there's property acquisition issues, you really can't, you can't solve the problem of finding the most optimal solution if you don't have all the data. Yeah, seeing as I made all this data up by simply drawing a line on this, well, I didn't make it all up. Somebody designed and built that road. You can see it in the surface. But now I'm working on my own design. I've actually moved the alignment away from the logging road, and I can obviously continue to change that, put it where I want it, and calculate the changes in cost, and see what the road's going to look like. Any change you make in a template, it's going to recalculate your cost. Let's see what happens to the cost of this alignment if I just, oh, and by the way, those of you who are familiar with balanced roads, oh, I see there's a question about that from Gord. Yeah, you want to make a balanced design, right? So you run the optimizer, get a solution. Guess what? It is balanced. Here's the design that we had before I recalculated. Now let's set it current. It's perfectly balanced. The cut equals the fill. Now you can put in pits, and it will use the pits. Borrow pits, generally you assign a cost. Waste pit, you don't assign a cost, but sometimes you can put in a capacity if you need to limit what goes in there. And it will use them, but I only put a pit at the beginning of the alignment. If I had put a pit here near this big fill, then probably it would use that pit to extract material if it's cheaper than pushing it down from here. But you never know. I mean, the optimizer figures that out, and it comes up with the best solution. So if you want a balanced road, just put your pits far away, and you will get a balanced road. If I change something, like, for example, the fill area on my design, here's the fill angle. So if I just change that a little bit, let's reduce the final fill slope angle to, say, 1.5 to 1. So it's a little steeper. Okay, and we'll do that on both sides. Before I recalculate, notice that we have a cost here, $497. I recalculate, and I haven't got auto process turned on. That'll make a difference. Mass haul, oops, now we've got material left over because we've reduced our fill. But it still should be a little cheaper. Let's just see what the cost is. Yeah, it's $493. It's not significantly cheaper. But if I now recalculate that alignment, I'm going to get a different alignment, and the whole thing should be cheaper. So again, a what-if scenario. We've got lots of questions. Let me just take a look here. Kyle Nelson is asking, can you force it to balance at different stations? Yeah, oh, this is a really good question. He's talking about a bridge. We call those obstructions, and the idea is you can't move material across the bridge until the bridge is finished, so you want to balance your road before and after the bridge. Currently, it's a little difficult to get Softree Optimal to do that. We don't have the option built in, but we have done some research in this area, and it is possible to include that as a feature, and it will be included in the future. Yeah, so in this situation, if I had a bridge in there, where is that? That cross section is, oh, by the way, it's finished, and it reduced the cost quite a bit. Now it's 444, and let's set that current and watch what happens to the mass haul diagram. So this is the qualitative view of cut and fill before I readjusted the vertical, and there it is after I've readjusted the vertical. Oops, let's get it to recalculate. And it's back to balance again. Now, right here, there's a bunch of fill, and if I put a bridge in there, and our software would allow me to do that, the optimizer will not, in general, zero the mass haul at that point. We don't have blocks or obstructions in the code as yet, so that's something that you'd have to manually deal with after the fact. Oh, there is a way, getting some good advice from the people in the office here. You can split the alignment into two pieces, and each piece would be balanced, and then you can join them together, because all you have to do is just change the station range here. So I could do from station 0 up to the bridge, calculate it, it'll come out balanced, and then do from the bridge to the end, calculate the vertical alignment, and then merge the two. And that's all in there. So yeah, that's a good solution. I hadn't thought of that. Thank you, Craig. Well, that's the main stuff I wanted to show you guys, and I'm happy to answer questions. So does anybody have any questions about how one could use the optimizer, or how I did anything on the screen here? Just going to do a quick wrap-up summary then, and we'll call it a day. So first of all, we started off with an alignment with nothing in it. We started off with a, let me just save this. Let's call it. Oops. So we started off with an alignment, a horizontal alignment. Now our software allows you it gives you lots of tools for calculating or finding your horizontal alignment. This horizontal alignment was relatively easy because it came from an existing alignment, and I just modified it a little bit to give me something that was a little bit faster, smoother curves. Given a ground horizontal alignment, I could calculate a vertical alignment with the push of a button, and it looks like this. There it is. So that green line was my vertical alignment. Then I can set that as being a road edge alignment, recalculate, and I can see all the curves and intersection points and so on that were created by the optimizer. Whoops, this one was created with some different parameters, so I got curves bumping right into each other. That's my mistake. Normally you would, well, not normally, but there are situations where this might make sense. It's just an option I had set wrong when I calculated that alignment. Then you can make modifications. At any time during design process, you can see the changes that you make affecting the cost of the every time you make a change. Let's say, for example, I delete this curve, it recalculates, and it re-updates the cost here. Taking a little bit of time, If it's taking too long, you can just turn off the auto process and do it manually after you've finished all your changes. You can do that same process with horizontal alignments. So let me open, I think I've still got it open. So once you have created a vertical and horizontal alignment, you can make changes horizontally and update the cost dynamically. You can update the cost for an existing alignment change very, very quickly using the cost calculation part of the software. And with a little bit extra time, you can push the process button and it will recalculate your vertical alignment for you. Then you'll get not just a new cost, but a new optimal cost for the horizontal alignment you've changed. And don't forget that while you're doing all of these things, you can make sure that the alignment that's being calculated is meeting your design specifications. You can do that by changing the control points, start, end, middle. You can do that by changing the station range. If you want to do a calculation before a bridge, make sure you've got a mass haul balance at the bridge point. You can also change your grades and curves. And as soon as this is finished, yep, there we go. I can show you that. You can change what sag and crest curve you have and what grades you have by station range. And you can put in control points anywhere along the road to fix the elevation or fix the grade. And you can have some variability there. And of course, everything depends on, oh, and you can put pits in. So if you really do have a good source or sink for materials, pits can save you money. We're working on some new features to allow you to force the optimizer to use material that might be coming from a side road or something, or force the optimizer to save material if you need it for a side road or something. We're also putting in more constraints to include things like full bench cut, overland. So if you want to force the optimizer to fill at least 2 meters in a certain station range, we're going to put in a feature for that. I think full bench cut is kind of obvious. Some areas you do not want to fill, so we're going to have a constraint for that. So we expect a few more constraint controls in here in the future. You can control how much it costs to cut and fill different materials. Obviously, solid rock, you're going to have to blast it. It's going to cost more to take it out of the ground. Another point I didn't mention beforehand is that when you build a road with RoadEng and probably most other software, you're going to tell the software what you're using for fill in various locations. The optimizer has to take fill out of the ground and then apply it along the roadway. And we use the quality factor to tell it how to do that. So for example, if you're specifying a fill of glacial till or common material, that material has a quality too. If you cut something like gravel, which has a higher quality, that's okay to use for fill. If you cut something like overburden, which has a lower quality, it's not okay for fill. So the software keeps track of what quality of material is required for fill, and then it can use the material that's coming out of the roadbed in appropriate locations. And again, it minimizes costs. So, you know, if you have material available, it's cheaper to use it in the road than it is to truck it out. It's going to use it. Okay, I have a couple of questions. Let's go on to them. I should have been paying attention there. Does the optimizer have the ability to design constraint to bridges alone? Yes, absolutely. You can put in a control point at a bridge, which would specify the elevation, and that will then the road will go through there. You can specify the grade of the bridge, it'll go through there. You can even specify that the bridge has a linear section. In other words, the bridge is not curved vertically. So yeah, you can design your bridge and then the optimizer will fit the curve to go through that bridge as you've designed it. The balance constraint, the only time the optimizer is actually constrained to balance the road is if you don't have a borrow or a waste pit. It's always going to use the pit if it's cheaper. And if you put a waste pit far away, you can put in a distance there, it's going to be expensive to truck material there. However, in a situation where filling is constrained or where filling is expensive, that's exactly what it's going to do. It's going to move the material to the waste pit because it has to go somewhere. So in answer to the question, Bruce, the balance is not binding at all unless you make it so by removing the pit, and it always picks the cheapest solution, whatever that may be. Oh, we got a cost of a question about cost. We are going to make this available to RoadEng customers. I'm not sure if I'm allowed to announce the cost, but let me just ask my superiors here if that's the case. Give us a call. I will tell you this, though, that existing RoadEng customers do get a very good deal if they want to buy Softree Optimal. Softree Optimal is an add-on for RoadEng now. It may be an add-on for other software later. And yeah, so if you're already using RoadEng, you are in a good position to just get the Optimal and start to run with it. It's ready to go. You would be using a beta version right now. We hope to have a release version out in a month or so, and it'll have a few more features. Question, shrink and swell, yes, absolutely. Just like in RoadEng, you can, well, if you're not familiar with RoadEng, you can change the quality of your material, and in fact, you can put in shrink and swell factors. Most people are working in bank cubic meters, so you would have your cut expansion factor set to 1 and your fill expansion factor set to something different from 1. And as different materials have different factors, they can be placed in the same location, and it makes sense. Your balance is correct. Your mass haul is correct. Somebody's asking about source and sink in the borrow waste pits, I assume, and that is less. Okay. This is the new feature that we've just added. I haven't even tried it, so I'm not going to show you how it works. But I will say that the concept here is that if you have let's say a crossing road, and you know that the crossing road needs material, you can put in a sink that has a capacity. And then the capacity, that material, let's say 10,000 cubic meters, will be put into that sink. So the optimizer will find a solution such that there are 10,000 cubic meters left over at this station, and the output will show you the results in that location. I think that will probably answer Les's question. So these are new features that haven't been even put into the beta release yet. They're just on my computer right now. Another thing that we've put into the software, now we're getting into the range of dangerous testing while other people are watching. So I will give the caveat that I might crash the computer. But one of the things that's important about running this software is what have I designed? Well, we know you've designed a vertical alignment. That's great. You know, in that vertical alignment, you can set that current, and you can now print it out as a design. I mean, this is a design. We're working within Rodench here. Rodench has the ability to print out your plan profile sheets, you know, save as land XML, export to DWG. We're ready to design. But one of the things that the optimizer calculates is Hall. The mass Hall diagram here is actually just an approximation of that. It's not the true Hall. So let's take a look. And this is where I'm not sure it's going to work, but we'll try it out. I'm going to show you the new Hall display that we're working on. So I'll put that in my profile window. There we go. And let's just make it a little bigger. And let's take a look at glacial till. And now I'm just going to reprocess the volume calculations. Okay, one more thing I have to change here. That'll do it. Okay, try again. Okay, I need to change the scale. Let's make it automatic. There we go. Okay. So this is a whole new way of looking at the, okay, I want that to be maximized, and let's zoom extents. So this is the mass Hall diagram on the, just underneath the profile, and then here we have the actual Hall of material glacial till, and as you can see, it actually matches the mass Hall pretty carefully. But the first thing is to notice is that it is actually, now why am I not getting the full thing? There it is. There's the full thing. It's matching it pretty closely, but this is just the glacial till. Then there's also the solid rock that's being cut and filled as well. What we see here is we're cutting along here, we're moving the material, and then we're filling down here. Now the yellow one is overhaul, so that's movement that's beyond a certain distance. The green one is freehaul. And yeah, so this is another way of displaying the material movement, and it is the information that's being generated by the optimizer. Let's see what the solid rock movement looks like. Okay. So there's only solid rock in this area, and there it is. We got some long movements here, and we got some short movements over there. Good. Well, I'm going to have to go pretty soon, so I'm going to shut her down. Any last questions? Well, thank you very much for paying attention, and this movie will be available, as we mentioned before, on our website. If you go to, well, there's the actual page. The easy way to find that is to go right to the front page of our software, of our web page, sorry. Click on free web seminars, and then look for the previously recorded web seminars link. Okay, thank you all very much.